and virtual provider that have only digital platform but not antenna 4G, 5G, for instance. I don't know, I think it's European-wide as well, this principle. But I understand that the regulation is not talking about common infrastructure. It was just launched as, to see your reaction, Stefan.
So thank you, Luigi. I saw that, yeah, the discussion triggered some tricky questions. So, okay, so now asking to the audience, and in line with what we already discussed, do you consider that additional measure to electronic conspicuity should be taken for manned aircraft to safely access U-space airspace? Just to clarify, like, the idea is that apart from being inconspicuous in the moment that you are crossing the limits of U-space, do you need to do something before or additionally? Okay, yeah, we are focused, yeah, in the moment we are living. So yeah, this is okay. Okay, I see that the audience is a little bit divided. So hopefully, if we have some time at the end, I'm not sure, but we can have more discussion about this. But thank you for your inputs, or if not, after in the networking drinks. So, what? Sorry. Well, I'm talking about which measure do you consider the most suitable? Buffer around U-space, as presented by Jean-Pierre, publish a tactical UAS non-fly zone similar to that, as Spain and Italy did, share live flight intent in advance before entering, or just other?
And all?
All of them?
All of them, it's possible?
It's possible. I think it's not possible multiple choice, but okay, but yeah, very similar percentages. So this means that people think that the three of them are necessary, or at least could be necessary. But yeah, apparently share flight intent in advance is the winner. Now you have to convince the manned pilots to do that. So. Okay, so going to the last topic, yeah, we have still some time remaining, while we are quite a little bit late in the schedule, but just to finish, we will talk about dynamic airspace reconfiguration. So here the concept is more clear. Is what is dynamic airspace reconfiguration? It's a temporary modification of the U-space airspace. Why this modification is done is to accommodate short-term changes in manned traffic demand, where inside controlled airspace, where U-space airspace has been designated, and how adjusting the geographical limit of U-space airspace. Just to clarify, when a U-space airspace is declared inside a controlled airspace, this part is closed for manned aircraft unless you are applying this dynamic airspace reconfiguration. So this is also a challenging procedure, and I would like to invite again Dani from ENAIRE, but also Alberto Giovino, Compliance Monitoring Manager from the flight, and also Simon De Boldere, from UTM Manager from Sky Eyes, to provide their insight and experience about this topic. So we will start with the question, how did your project implement DAR in practice in terms of sectorization, procedures, and what are the roles involved? So maybe we can start with Alberto.
Yeah, thank you very much, Marina. It's kind of a long story, and I only have a few minutes to make it short, so I'll do my best. My colleagues presented the Italian cluster solutions, and you could also see demonstration of the dynamic explosive configuration. So you've seen how it works. ATC initiates the process, so somebody takes action on the CIS platform, and a zone is created in the geozone, so it becomes red, and this is in terms of HMI, and also a window pops up telling the US operator that dynamic explosive configuration is taking place, and you cannot hear it, but there is also an oral alert, which is quite strong. You cannot miss it, believe me. This is, of course, if the US operator makes use of the information through an HMI, but since this is a modification of the geo-awareness, if the US operator makes use of the input through data import in its own platform, it will work as well, because it will trigger geofencing systems, and the drone will find itself compelled to leave the area. Now, who is this entity which takes action by input from ATC? And my colleagues mentioned the Innovative Air Mobility Coordination Center, so I'll take a couple of minutes to try and make you understand what it is. Those of you who are familiar with the conventional aviation and air traffic services would know what an aerodrome reporting office is. The aerodrome reporting office is an ATS unit, and it used to be present at every airport provided with ATS, and it used to be the place where pilot went to file their flight plan, get their weather folder, get their pre-flight information bulletin, so the NOTAMs, anything that they needed to perform their flight, and anything that ATS needed to know to provide them with services. Now, technology went on, things changed. Years ago, INAV had the idea of centralizing the aerodrome reporting offices. So we stopped having an aerodrome reporting office at every airport, and we created two central briefing offices, one in Milan and one in Rome, and they were providing these services for all the airports all over the country. So we had these two ops rooms, which are 24/7, 365. They're always open. And years ago, we started training people there and using them also as an interface between basically aerodrome control towers, airport control towers, and US operators in case of drone operations authorized in the vicinity of an airport. There is a national regulation which says that when there is a drone operation authorized near an airport, this operation shall take place in coordination with ATS in order to minimize the impact on the airport operations. And we had the idea using the Rome Central Briefing Office, and we, of course, trained people to be the interface between control tower and drone operators. And the reason was that we realized at the beginning that these two entities did not speak the same language. Drone operators were often not familiar with ATC procedures, and in coordinating directly with control towers, there were several issues. So we created a bunch of people who were capable of speaking both the languages, and they were able to manage this kind of coordinations. So this was before U-space. It happened years ago. When U-space came up, it was kind of obvious for us to think of them to also be the dynamic aspect configuration manager, because the activity is very similar. So basically, that's our That's our view. This has, of course, pros and cons, as everything. The great advantage is that the additional workload for ADS is close to zero. All they have to do is to initiate the dynamic SOC configuration by triggering the IAMCC. Then the IAMCC will do all the work. They act as a stakeholder of ADM on the platform, so they take the action that you saw on screen, they create the area, blah, 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 anything that you could see. One potential negative side would be that the communication chain gets longer, of course. We introduce an additional element in the loop, in the chain. But if you think about it, most likely this could be, in the end, an advantage more than a disadvantage, meaning that if the action which is required by the control tower or the ATC unit anyway is kind of lengthy and complicated, there is a good probability, mostly in high-density ADC environment, that this will be postponed. They will be busy doing something else first. So if the only thing they have to do is to make a 5 seconds phone call or to push a button, they will do it. They will start the process. If they have to sit down, log in, open the mask, put the data, and then the blah, 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 most probably they will have something else to do first. So in the end, the chain will be longer, but the rings in the chain will be shorter. and in the end, this could really be a positive effect. There are many other things that we might discuss about the solution, but we do not have much time on that. And so any questions or anything that you might have ready to answer them any time. Thank you.
Thank you, Alberto. So maybe we can jump to Simon.
Yeah, so I would like to, first of all, make a few elements rather clear about dynamic airspace reconfiguration and the implementation within the BURDI. So, BOLT, we didn't implement in terms of, we understand implement as being the tool is available, ATM personnel is trained, we have our tools which are DPO cage compliant and so on. Those are all elements that within the framework of the project was just not possible. So it means that your airspace should have been gone through the complete ARA process, being published and so on. So U-space and controlled airspace within the project, no. So what have we done in that thing? Well, first of all, let's understand as well the Belgian context. As already said before, we have quite a lot of operations already in Belgium, about 16,000 in our CTRs every year, which are authorized. We already have a big bunch of geozones. Last time I counted, this week it was 649, of which of them all the CTRs are subdivided in geozones. So we already have quite an elaborate UTM system. I'm not calling it U-spaces, but UTM system, which makes the challenge, and I'm gonna use the Dutch word, it's the geremde voorsprong. It means that we've already advanced quite a bit in how to use our airspace, but that makes that if we now make changes, it needs to be a change that increases capacity, that increases the way of working, that really delivers an improvement. So that's why we didn't advance in implementing U-space in the CTR at this moment. But for example, we described our CONOPS. We described the CONOPS that takes the ATCO as the central part in dynamic airspace reconfiguration, where we try to limit as much as possible his impact. So one of the options that we saw is linking, let's say, a standard U-space configuration to the existing geozones already. In Belgium, those are called VLL 1, 2, and 0, for example. So subdividing those more, making use of data coming from the ARA, being low-level inspection flights and so on, so carving up the J-zones a little more, and that results in a standard configuration for the U-space airspace that is based on the runway in use. So by the activity of just changing runway in use, it would change the available U-space airspace in the CTRs. Of course, that is the nominal situation. You always have abnormal situations where ATCOs are, via manual intervention, able to make a change, close the airspace. We already do it today with our UTM platform. We have a ground all drones button, for example. That's a very first implementation of what is potentially a DAR execution. But for U-space, we envision it to be more dynamic. to not close the complete CETAR, but to close maybe smaller blocks for small, let's say, pipeline inspections passing by or other aircraft passing by. So that's what we did up until now. What we see is that the data coming from that action executed by the ATCO, those are directly ingested or injected into the data flow of geographical data at the CISP, where it is made available for all the data subscription of USSPs. So you don't need to add another data subscription as USSP if you want to have your DAR data. And on top of that is really the conformance monitoring is a key role in that. Conformance monitoring will help, for example, the acknowledgement of DAR implementations in our concept of operation. Other details I can explain more maybe outside of this conference room, at the booth, whatever, but that's how we implemented it. Implemented in a test phase, so we have our test platforms ready, but implemented as being up and running, no. We have done the CONOPS, we have implemented it in a test environment, but that is as far as we went with this implementation.
Okay, I will try to be brief. Well, regarding to the system, you already saw this morning how is the dynamic aspect reconfiguration, but as you could see, it's not integrated in the ATM system as such. Okay, that's an initial barrier, but we are going to start with that. So we presented to the traffic controllers at ENAIRE how is the system. The future will be integrating in the ATM system, but if you are familiar with this kind of evolution, it will take years to integrate it in the ATM system. So we will have to start with this additional screen. So we have additional screen. So in ENAIRE, air traffic controllers cannot use that, okay, because of the workload. So who is going to do it? Talking about the roles, the supervisor, because we have always supervisors in towers or in the ASCC. Depending on the control, where U-space is declared in controller space will be or the ACC or the tower, the closest airport, the responsible of doing this dynamic space reconfiguration. So far, we have already developed the CONOPS, the general CONOPS, not a specific CONOPS for a U-space volume, but the generic CONOPS, and also the safety case. So that is already done. So what is pending? We are pending on having a control, a U-space project that is not started yet in ENAIRE controller space. And so, of course, we will have to develop a specific CONOC and a specific safety case. So because in every tower and every ACC, they work, it's similar, but can be some different. Sectorizations, we are going to start with only one sector. Okay, it's not going to be multi-sector. It goes against efficiency airspace, we know that, but goes directly to the highest safety, the highest safety. So a traffic controller doesn't want to start with any sectorization. We expect that the U-space volume is going to be small, so maybe it's not going to be a big deal, but of course, with big U-space volumes, the sectorization will be something to take into account, of course, and that's the objective. And as Simon mentions, this is one of the reasons that conformance monitoring is going to be mandated, because it's needed in case that you exit the U-space volume and you get into controller space. It's quite critical, so this alert has to be in some way to be sent. So it's one of the main reasons that in the airspace risk assessment in general, the conformance monitoring will be mandated.
Okay, thank you, Danny. And we have 2 minutes to finish. So just last question, yeah, in a few words. Well, you said that you really didn't implement like actually the dynamic airspace reconfiguration, but can you say a few words about the ATCO feedback in case you had it? What is, and also what are the open points for the moment, like just few words about what are the open points about ATCO workload, notifying operator, make sure that the information is arriving to the operators, and few words to close.
Okay, so far so good. As Rodrigo mentioned, we will receive some feedback from them with colors, things, information of the tags, of the drones. They want to know the altitude also, and some kind of things in case of this dynamic airspace reconfiguration. Of course, they are not going to be checking the information of U-space, only in case of dynamic airspace reconfiguration. This is important. It's not going to be a air traffic controller looking to the U-space information. And of course, there will be evolution of how to improve the tool, but so far it's enough for starting with in the first controller U-space.
Yeah, so for Belgium, as already said, we're focusing on using that runway in use as a trigger, so to reduce the workload of the ATCO. Another element which is still open is today U-space is up to 400, 500 feet max. In Belgium, the CTRs are geozones up until the top of the CTR. What do we do with that portion above it? That's really one of those questions, because not solving that element would mean that an ATCO is doing dynamic airspace reconfiguration in the lower part, and then whenever a drone is flying at 502 feet, he'll have to do another flight authorization process for a geozone. So you have to tackle that kind of approach to solve that, so that the workload of the ATCO is really manageable. That's one of the most important things. And one of the open topics, it's really the DPO and the cage compliancy. It's a 373 regulation, it's an ATCO activity. So whenever you have new tools, new instruments being installed at ATM environments, you have a lot of paperwork and a lot of work to do in order to have it authorized to be used by an ATCO. So that is really on the backlog. It will be quite a lengthy work in my mind, yeah.
Okay, obviously controllers are very happy with the solution. It was mentioned before, we could check the solution in the U-ELCOME project and in some demonstrations and trials we did, but we could not do it in real life because we don't have controlled spaces. Ironically, we do have a deactivation procedure standing while we're speaking at San Salvo, although it is uncontrolled airspace, because this was our regulator's decision. So while we are speaking, it happens in real life, and it happens more often than expected. Helicopters fly there. I wasn't expecting that much. So basically, the main shortcoming that we currently have, in my view, is that we do not properly close the loop, meaning that the published procedure only says that the helicopter pilot tells the Flight Information Center to deactivate. The Flight Information Center calls the coordination center, they deactivate, and they give feedback to the Flight Information Center, say, it worked, we could deactivate, we could see change on screen. The Flight Information Center assumes that after the published time, every drone is out, but we do not have an actual confirmation that everything worked so far. All we have is a mitigation procedure which tells US operator, if you're unable to comply within the required time, make a call to the coordination center. Raise your hand and say, no, we have a problem, we're not out. So if nobody says that they have an issue, it is assumed that within 10 minutes, everybody will be out. This is not, I mean, it has to be improved. We're fully aware of that. And we do believe, and I'll finish, that the final feedback closing the loop should be generated by the USS platform. We don't think this is something we will ask the controllers to verify. We want the USS platform to say all flight authorization are stopped, all granted flight authorization are revoked, no network IDs are in the air. And when these three conditions are verified, it can tell ATC, go. So this is our main shortcoming so far.
Okay, so thank you very much, Alberto, Simon, Dani. And with that, I'm closing my presentation. So I just wanted to thank you, all the experts that took part of this discussion. You helped me a lot to make this more dynamic. and enjoyable by the public. So thank you very much. And also talking about the U-space implementation handbook, I invite you to read it, to tell us what you think about this document, and also, of course, thank you very much to all the U-ELCOME team that was leading this process, and that was not easy all the time, but we did it. And of course, also thank you to the other DSDs and the other people that collaborate and took part of our workshops and provide very valuable inputs. So thank you very much, and that's all. Thank you.
Thank you very much. So it's been a day full of discussion, very dense, very, very dense. And I don't envy Cengiz, because he's in charge now of summarizing a day of exchanges.
Summarizing. In fact, the three DSD are a challenge. Then in SESAR normal methodology, then you do projects, exploratory research, industrial research, you end up with TRL6, and you have a set of documentation that we call a data pack that contains technical specification, operational environment with the OZ, CBA, demonstration, validation report, contextual note, voilà. We have a set of documentation that is, let's say, the SESAR solution we call data pack. And afterwards, out of that, SESAR deployment manager, for example, take this data pack and move from TRL6 to TRL8 or 9. In this context, we asked those projects a challenge. We said, go to TRL8, but without any documentation except the regulation. Then this is why this handbook that was presented is a key document. In fact, this is the document that if we have a time machine, we put on the machine and we send it back to Patricia and say, Patricia, voilà, this is the data pack, you can start with that. And I think she would have been very happy to have this handbook in hand and progress with the project. In this respect, this handbook is key. Then we consider this as being a data pack. This is a document we deliver to the SESAR deployment manager. In annex, we will put BURDI, U-ELCOME, ÉALÚ-AER as use cases, as example in annexes. And this document will be, let's say, if you are in any of the other 6 countries, except the 6 countries that were a part of the projects at ECAC level, and you would like to implement U-space airspace in your environment, please take this handbook. Then this is what I wanted to say as a conclusion, the importance of this handbook, the time we spent on that. Here, we had the 3 topics that we discussed. There are 70 topics inside the document. It has been challenged. Some solutions have been brought inside. It's not the picobello, we say in Belgium, solution, but it's a solution. Then this is what I would like to conclude with and give the floor back to my colleague, Christelle.
Thank you, Cengiz. So before calling it a day, we have 2 important endeavors. The first one is the group photo, and you'll have to organize yourself as efficiently as possible if you want to enjoy the second one, which is the networking drink. So I invite you all to come here, stand, organize yourself, make the use of the circle room here. I'm going to get the exhibitors